Now, you know how LLMs generate text token by token. But what is a token? And why does the model need to break the text into tokens in the first place? In this video, we are diving into tokenization, the bridge between human readable text and the numbers that LLMs actually work with. Let's go! Imagine you are trying to teach a child to read. Instead of diving straight into complex paragraphs, you'd start by introducing them to individual letters, then syllables, and finally whole words. In a similar vein, tokenization breaks down vast stretches of text into understandable units for machines. Tokenization in the realm of natural language processing and machine learning refers to the process of converting a sequence of text into smaller parts, known as tokens. These tokens can be as small as characters or as long as words. The primary reason this process matters is that it helps machines understand human language by breaking it down into bite-sized pieces, which are easier to analyze. Now that you understand why tokenization exists, let's look how it actually works. There are three main approaches. First is word tokenization. This breaks text into individual words. Hello world becomes hello world. Is the simplest approach and works well for English because English has clear word boundaries. But word tokenization has a problem. What about words you have never seen before? What about chatbots? If the model was trained on chat and bot separately, it does not know about chatbots. It's an out of vocabulary word. Second, character tokenization. Break the text into individual characters. So hello now becomes HELLO. This solves the out of vocabulary problem because you only need 26 letters plus some punctuations. But now every word becomes many tokens. That's inefficient. That's why subword tokenization is the sweet spot. You break text into units that are bigger than characters but smaller than words. Chatbots now become chat bots. Unhappy becomes unhappy. This approach handles unknown words, it's efficient and it preserves the meaning. This is what the modern LLMs like GPT and Claude use. When you use an LLM, tokenization is the first thing that happens. Your prompt gets tokenized, the model processes the tokens, and the output is generated token by token. But tokenization does not just matter for LLMs, it's fundamental to all NLP tasks like machine translation, sentiment analysis, text classification, name entity recognition. They all start with tokenization. Even when you are working with tools like Spacey or NLTK, tokenization is happening in the background. Every time you parse a text, break it down, or analyze it, tokenization is the first step. Without proper tokenization, the rest of the pipeline breaks. Bad tokens mean bad results downstream. That's why understanding tokenization is crucial. Now, here's the most important part. Tokenization sounds simple, but it comes with real challenges. First, ambiguity. Language is inherently ambiguous. Take the sentence, flying planes can be dangerous. Depending on how you tokenize it, it could mean piloting planes is risky or planes in flight are dangerous. Same words, different meanings. Second, language without clear boundaries. English uses spaces between the words, but Chinese, Japanese, Thai, they don't. Where does one word end and another begin? That's a fundamental challenge. Third, special characters. Real text has email addresses, URLs, hashtags, emojis. Should john.doe@email.com be one token or multiple tokens? There is no obvious answer. Fourth, out of vocabulary words. New words, technical terms appear constantly. Your tokenizer has to handle unknowns gracefully. To address these challenges, researchers have built advanced tokenization models. XLMR handles over 100 languages. MBART uses word piece tokenization to understand syntactic and semantic structures across languages. These models use shared subword vocabularies So tokenization works even in languages that traditionally were hard to process. Now, you might be wondering, how do I actually use it? Do I build a tokenizer from scratch? The answer is no. There are excellent libraries and tools already built that handle tokenization for you. Hugging Face Transformers is probably the most popular one. It's a Python library that gives you access to thousands of pre-trained models, and tokenization is built in. You load a model, pass your text, and it tokenizes automatically. Spacy is another powerful library, especially for NLP tasks. It has fast, production-ready tokenization. If you are building a text processing pipeline, Spacy is often the go-to choice. NLTK, Natural Language Toolkit, is one of the oldest and most educational. It's great for learning because it's simple and well documented. It's perfect if you're just starting out. And then there is TikToken, which is OpenAI's library. It's specifically designed for tokenizing the text the way GPT models do it. If you're working with OpenAI's models, TikToken is essential. The key point is, you don't need to build tokenization from scratch. These tools handle it. What matters is understanding what's happening under the hood. Which brings us to our next video. You now understand what tokenization is, why it exists, different types, where it's used, and the challenges it presents. But we are only scratching the surface. How does the tokenization actually work by algorithm? How do the modern system tokenize the text as scale? There's what we are diving into the next video. If you find this video helpful, like it, subscribe to my channel, and hit the bell icon so you don't miss the next video. And if you have any questions regarding tokenization or want me to deep dive into a particular topic, drop a comment below. I will see you in the next video. Till then, goodbye and happy learning.